In this lesson, we're going to learn how to do some web scraping using Python and a Python library called Beautifulsoup. In our last lesson, we talked about how to get data by using web services and then using the APIs of the particular web services. Not all companies expose their data that way, and so if we need to get some data and that data happens to be available just on web pages, then what we can do is scrape out the data using Python and a couple of extra libraries. So here is a list of some libraries that are available to use for web scraping, and we are going to be using the library called Beautifulsoup. Now we'll also need to use a couple of other extra libraries. Just like last time when we had to use the requests library to handle our HTTP requests. We still are going to be making HTTP requests again, this time to bring back full web pages with colors and design and pictures and everything. We're going to be making requests, so we need to use that requests library. And then we're going to use the Beautifulsoup library to scrape the data out of those web pages. Then we're going to use pandas to do some data analysis after that. Now, if we're going to be requesting full web pages, then we're going to be needing to be able to look into a bunch of HTML, because web pages are usually sent to the browser in the form of HTML code. And now you don't really have to be real familiar with it. Some of you might be familiar with HTML, and you don't have to know a whole lot about it in order to accomplish web scraping, but you do need to know a few basics. So first of all, I wanted to just go over that, just some of the basics, so that you can look in HTML and kind of know what's going on, whether or not you know all of the details. At least I want you not to look at this and think it looks like Greek. Okay, so here is some example, some HTML code, and notice that there's the first tag. We call these tags that are inside these brackets, and the first tag is an HTML tag. That's just saying, here comes some HTML. Now that tag has a matching end tag. We're beginning the HTML, and then when the HTML ends, we see the end tag. And notice the end tag looks a lot like the beginning tag, but there's a slash. So that's saying now we're done with the HTML. Here we have a beginning tag for the head. There's usually just kind of in a web page, there's what we call the head, which will have, first you can see here, there's the title. It's going to tell, put in there what the title is. That will be included within the head of the HTML code. And also, if there's some JavaScript, that many times will go in there too. But anyway, and you don't have to worry about this, but just know that this tag says, okay, here comes the beginning of the header, and then you see the end tag there. Again, it looks just like it, but with a slash in front. Inside the head, we see a beginning title tag and then an end title tag. So everything between those tags would represent the title. So for this page, we would know by looking at this that the title of the page would be called index. And what that represents is what you will see in your browser on the little tab, like when you are looking at a web page in your browser, and maybe you have several web pages open and you have tabs along the top of your browser. The title is what shows up in that little tab. Okay, now we start the body part of the web page. And so this says, okay, and here comes now the body of the web page, and then we have an end tag here too. And then inside there, we have this type of tag called div. It's just kind of short for division, and just a little. It's just saying, hey, here comes this little block of some content. So that's the beginning div, and then here it has an end div. And then inside we have some other some text that's basically going to show up on the page. The page is going to say, we're going to have an exciting party and you are invited. In front of the you're going to have an exciting party, there's a P tag, which is a paragraph tag, and then an ending paragraph tag. So basically that just makes sure that that text will start on its own line, and then when it's finished, then nothing else will be written on that line. Any content coming later will be written on a different line. And then we have another paragraph tag, and inside that is the words "and you are invited," and then the end tag. Now the BR tag is a tag that doesn't require an end tag. Sometimes you do see that a little bit different with a slash inside that, but inside the BR, but at the end, don't worry about that. But anyway, BR just stands for break, like a line break. If the text has just completed and we want anything that comes after it to begin on another line, we could put BR. So to just say, make a break, start on a new line. And because that's not something that has to be encapsulate some content, like most of these others are kind of encapsulating content, the BR tag is just saying go to a new line. So that doesn't require an end tag. So sometimes you'll see that, but most of the time within tags you see a beginning tag and its end tag eventually. Now, many times within a web page, you'll see that tables are used, HTML tables. A table is something that's kind of like an Excel file that has rows and columns and usually a header along the top. So here is some code that could be used in order to create a table in HTML. Here we start with a beginning tag of table. And inside this beginning tag of table, it also says class equals something here. So we'll talk about that here in a minute. We can do that inside our tags, put some extra information. So I'll talk about that in a minute. But anyway, for now, just look at that beginning tag as the beginning table tag. And then way at the end, here you see the end table tag. Then each row starts with a TR. So that's a table row. So you see the first block, there's a TR, and then there's some stuff inside, and then there's an end the end tag for the /TR, and then there's a new TR, and then an end TR, and so on. So you see it looks like there's going to be 3 rows represented in this table, in this HTML table, because there's 3 blocks of TRs. Okay, then you also see inside those TRs that the T. Let's talk about the TDs first. So ignore that first TR block. That first TR block has some THs in there. We'll talk about that in a second. But the next 2 TR blocks have TDs in there. So TD, you can think of that as meaning table data. It's basically what is going to go on each row. And so that represents what's inside a certain column for that particular row. So for that second block, there's a TD says John, and one that says Smith, and one that says 29. So this would be a table. You can see that there will be 3 columns in this table, and on that second row, for the first column you'll have John, second column you'll have Smith, and third column 29. So each value that starts with a TD just represents a column within that particular, well, not a column, but a value within that within that row, and then when you have a bunch of rows, that ends up representing a column. Now, the first row, going back to that first TR block, that doesn't have TDs, but it has THs. And that's because a lot of times that first row, we want that first row to be a header for the entire table. And so if we put TH instead of TD, it's going to be bolded. It's going to stand out a bit by being bolded, and in some cases we'll have some other different style in there to make that first line look different. But anyway, the reason it's called, it has a TH tag instead of a TD tag, is that this is our header, table header. So we're going to have first name, last name, age. That's going to be the first row, and it's going to be bolded because it's the header. So it's important to be able to understand this table structure, because a lot of times when we're doing web scraping, we're looking for data inside some of this, this table HTML code. So just be aware, there's the beginning and end table tag, and then there's the TRs that represent the rows, and then the TDs or THs that represent the elements within the rows. Now, here we had noticed that this first tag of table had something else in here. It says class equals, and then I just have in there some name here. So anything can be in there. So sometimes in any kind of tag, we might see something like this that says class equals something. Now, that's class there is usually there so that when the page is rendered in the browser, a lot of times we have style settings using, like, if you might be familiar with CSS, which is cascading style sheets, and you may not be familiar with that. But anyway, that's just a way that style, meaning colors and fonts and things like that, can be applied to our data. There would be some code somewhere else saying everything with this class should be red or something like that. So anyway, a lot of times that's why we use why they say class equals something, is because some style is going to be applied there, because there's code somewhere else that's going to make everything in that class a certain color or something like that. Okay, so anyway, it's important to know about this, because a lot of times when we're doing our web scraping, we're going to find our data inside tags that have certain classes associated with these tags, and we're going to be wanting to really be aware of where do we find these different individual parts of data, and is there a class associated with these different tags, because then we're going to reference that class within our Python. Okay, so anyway, just to recap, for any tag we might have class equals something, and whatever the name is, the person who's writing the code can put any name in there that they want for the class. So anyway, for our sakes, just know that a lot of times we want to be watching carefully to see where our data is being, where our data lives, and a lot of times it lives within some tags that have a particular class name. Now, sometimes when you see HTML, it's not going to be formatted nicely, and it's going to just kind of be all on one line. And so it's definitely harder to read like that. But just know when you see stuff like that, know that it's still not as difficult as probably it appears. You could always take that and kind of, put some line breaks in there in order to be able to tell what's going on. But really, all of that is just exactly what we just saw. It's just that it's all put together, one after the other. Now, and if it is put together like that, one after the other, it's not a problem. The browser is going to read that HTML just fine and go ahead and display that web page just as if it had been formatted well. So how do we scrape data from a web page? So what we're going to do is we're going to write a Python script that brings back all the HTML on a given page, and then we're going to figure out how we can identify which particular tags hold the data that we want. So here in this example, I just made up some names. Okay, I don't even know what they mean, and a lot of times the class names do just have words or letters like this, and you don't really know what they mean, and you don't really care. But we're just going to look here and see, okay, the table itself has a class of FS block major. Then that header, the table heading, that first row, doesn't have any classes involved with it. But then the second row has 3 different classes. One is for the first name. That first one is the first name, and it's FN, and then those letters, and then the other one is LN, and then the next one is A. So, we can sometimes you can kind of tell what these classes mean, and it looks here that maybe FN stands for first name and LN stands for last name. Again, I just made these up, so that's what I had intended, for FN to stand for first name and LN to stand for last name. A doesn't seem to stand, oh yeah, that would be age. If that says age is 29, then A probably stands for age. Anyway, notice then the next line, we have those same classes. FN for first name, LN for second name, and A sorry, FN for first name, LN for last name, and A for age. Now, here's what we would say. If we were trying to get data out of this table, we'd say, it appears that all of the first names are within a TD element with a class called FN-CNTNT. And the last names appear in TD elements with a class of LN-CNTNT. And the ages seem to appear in TD elements with a class of A-CNTNT. That's the observation that you need to be able to make in order to do the web scraping. You're kind of being a detective. When you find a web page and you want to scrape data from that, you look within the HTML and you say, what's the pattern here? Where is this data that I'm trying to get at? And in this case, we would have come to this conclusion that now I know how to get the first names out because those are in tags, TD tags with this certain class, FN, CNTNT, and now also I know how to get the last names, and I know how to get the ages. So that's the first step for web scraping, is first of all figuring out where your data is and coming up with that pattern, knowing where would I go to get that. Now the thing is you could just say, oh, I can tell what's the first name, what's the last name, and I could just copy and paste all of those out and do it yourself. But the thing is we're going to have the computer do it for us. We're going to write a Python script to do it. So that's why we can't just say, oh yeah, it's obvious what the first names are, what the last names are, and we'll just go ahead and do it ourselves. We're going to have to be talking to a computer. And so when you talk to a computer, there's not the intellect that we have going on with a computer. So that's why you have to be very specific, and you would have to say, okay, to get the first names, you go to TDs, with classes of FN, CN, TNT, and to get last names, you go to these other ones, and so on. So we're just kind of coming up with something that we can then eventually tell the computer to do in order to get the right data. Here's another example. I just kind of have a lot of the same information, but I've changed some classes. If this were the case, what would we say? We would say, well, it appears that um, the first um, the first line of actual data is in that TR tag that has a class of FS block major. And then we might, in our mind, say it looks like the first TD is the first name, the second TD is the last name, and the third TD is the age. And then we'd say, and then the next line has that same class of FS block major, and again, it looks like the first TD is the first name, second one is the last name, and third one is the age. So what we would say in this case here is we'd say, it looks like each record of data appears in a TR element with a class of FS block major. Then the first name appears in the first TD, the last name appears in the next TD, and the age appears in the third TD. So again, that's the kind of thing that you would have to narrow down and be able to eventually tell the computer within a Python script. And being able to come up with describing where the data is like this is key in order to be able to scrape the data. Here is a page from a Zillow search, and you see the page over on the left, and then the code that the HTML code that was used to display that page over on the right. And I'm going to show you there is a demo, a video posted called Zillow Demo that you'll be able to watch and see how I found this HTML code and then how I was able to identify exactly where this data was within all of this code. But if you take a look at this page, you see that what it is, it's a list of some houses based on a certain search, and I searched most expensive to cheapest in Olathe. So this first one happens to be $8 million, probably because of a lot of land, because it looks like the house only has 3 bedrooms, so probably it's $8 million because of a lot of the land and maybe some other buildings on the land. So anyway, where we see over there on the left, it says house for sale, $8 million, 3 beds, 1.5 baths, and then it has this square foot, but that's kind of covered up there. But anyway, and then it also has the address. So over looking at the HTML, you see, looking carefully, and this might, hopefully it's not too hard for you to see. It might be pretty hard to see, but it looks like the price is within a span tag with a class called ZSG photo card price. And the number of bedrooms is in a span tag with a class of ZSG photo card info, and then there's one with a couple of other spans that holds the number of bathrooms and the square footage. And then you see there's another span with a different class called ZSG photo card address with the actual address in there. And that can be sometimes a little hard to find because a page like this is going to have a lot of HTML in it. But take a look at my demo called Zillow Demo, and you'll see how I was able to narrow down and find that. But once we find that, we could pretty much know that all of the prices of all of these houses are within these spans with the same class of ZSG photo card price. And all of the bedrooms, however many bedrooms, are within these other span class with these other classes of the photo card info and so on. So then what we would do is write a Python script to say, take all this HTML, find all the span tags, for each block, for each house, find the span tag that holds the price, and save that price in a special list, and then find out how many bedrooms, save that, and save all this information into some different lists, and then do that for every house. And then you'll eventually be able to put all of that data within a CSV file and then have that data available to use for some data analysis if you'd like. I've included a URL here on this slide so that you can use it to go and find the documentation for this library called Beautifulsoup. I don't think you'll need to go in and look at that. Everything that you need to know for your lab, I think, will be, I'm talking about here right now in this video. So I don't think you'll need to go and look at this anymore for what I'm giving you. But if you want to just have this as a reference for later, in case you do want to kind of delve into that a little deeper, this is the URL for that. Okay, so here's what the strategy is going to be that we're going to use. We're going to use the Beautifulsoup library to go through the HTML code and pull out the data that we want. And we've just talked about how we would be able to know where that data is. We look for which tags is that data in. Do those tags have a class associated with them, or is there some way we can identify where in the HTML that actual data that we want is? Then we're going to store that data in some different Python lists, and then we're going to merge the lists together to make a data frame. And then we'll have a data frame that we can then use and pull into pandas and do anything that we can do in pandas with that data. There are some things to keep in mind when you're doing web scraping, and I got this list from the Free Code Camp website. And first of all, the first one says you should check a website's terms and conditions before you scrape it. Be careful to read the statements about legal use of data. Usually the data you scrape should not be used for commercial purposes. So just be watching for that, and if you're doing something that's going to make you a lot of money, or then you're going to want to make sure you follow everything correctly, or you might get in big trouble. Number two, you want to be careful, because if your Python script requests page after page very, very quickly, and a Python script, any kind of computer programming, the code goes by very, very quickly. And so if your Python script actually is pulling up one page after the other, if it is allowed to go as fast as it can, it will be requesting different pages from the same website, many times, possibly within a very short period of time. And that can cause the server to have issues if there were too many requests coming in all at once. Okay, so let me go ahead and read this number 2. Do not request data from the website too aggressively with your program, also known as spamming, as this may break the website. Make sure your program behaves in a reasonable manner, acts like a human. One request for one web page per second is a good practice. So for instance, if you are writing a Python script and you want to, let's say for this Zillow example, there's only maybe 20 results on each page, and then you would have to hit the tab button in order, the next page button in order to get the next 20. If your Python script is getting 20 and then going to get the next 20 and get the next 20, then just slow down that Python script using like a delay. There are different types of commands that you can use to just say, hey, wait for 1 second before you do anything else. So you're delaying your what's coming next, so that way it looks more like a human being is actually looking through this and not a computer that's going so fast. And that way, again, there's not the danger of going so fast that it too many requests in a short amount of time, and it could break the website. Okay. Also, this is important to keep in mind. Websites change, the layout of websites change from time to time, and make sure to revisit the site and rewrite your code as needed. In fact, there have been times where I've created an example here for this particular class in this lesson for web scraping, and the next semester I would try to use it again, and it no longer works. That code no longer works, because all a company would have to do is change their website and change some of the tags and change the class names, and then our Python scripts that we've written would no longer work. So keep that in mind. Just because it works one day, it might not work 6 months from then. So you just kind of have to try it out and see if it works. And if not, then you have to go back in and kind of do it all over again, where you investigate and say, what are the tags that hold this data that I need to be able to find? Okay, so we're going to do an example where I'm going to scrape some data from the IMDb movie website. So what I'm going to do is look up the most popular movies according to IMDb. So what we can do is go to IMDb, and under movies, TVs, and showtimes, I I dropped down that drop-down box and looked under movies and found top rated movies. So if we wanted to find the most popular movies according to IMDb, then that might be what we would find. So what we would use. So we could go ahead and click that link, top rated movies, and then bring up another page that hopefully then would be a list of these top rated movies. And here's the page that we get when we request those top rated movies. You see that there's a list starting from 1 down. We see the top 5, but there's more below that we aren't seeing here. The rating is from the IMDb rating. The top 2 are 9.2, and then they go down from there. Now, what we would want to do, first of all, is before we do anything, is take note of the name of that URL. So we would look and see, okay, in that address bar, we see that we have that particular URL. So we would write that down, type that up or something like that, and put it off to the side so that we're going to be able to use that in our Python script. Now, I should have said this before, but probably go ahead and try to use Google Chrome for the browser, and open this page in Google Chrome. The reason why is that my directions are going to be specific to using that browser, and the instructions are a little bit different as far as how to find the HTML code for different browsers. So if you can, go ahead, open that page in Chrome, right click on the first title, so Shawshank Redemption, right click, and then you have some options to choose, and then choose Inspect. When you choose Inspect, then over to the right you will see a window open, and it shows a bunch of HTML. That's the code that will then eventually that then eventually renders this page that you see on the left. Now here's again where you kind of have to look through here and try to figure out where all this information is. One thing to keep in mind is you see at the beginning of each line there are little triangles. Sometimes the triangle is pointing to the right, sometimes it's pointing down. Now if it's pointing to the right, that means that there's more that's not showing up. And if you click on that right triangle, then the triangle turns to point down instead, and then all of the stuff inside there expands. So for instance, it's kind of hard to see here, but look under here for this HTML, look under the class called title column. It says TD class title column. See that little triangle is pointing down, and you see that it's been expanded, and you see everything that's inside there. You see inside this title column, you do see the title here. Eventually it says The Shawshank Redemption, and then it has the movie year there too. Now if you were to click on that triangle, that down triangle, the triangle that's pointing downwards, then all of that stuff that has been expanded, it will be compressed, and it will all be compressed into one little line like that you see in the line right above that says TD class poster column. Okay, so anytime you see a triangle pointing to the right, you know there's more in there, and you can expand that and look inside that and see what's in there if you think what you're looking for might be in there. Okay, so anyway, we see that the title is in that tag called TD class equals title column. And then if you click on the right arrow next to the TD class rating column, IMDb rating, then you see, and actually that's already been in this picture here, you can see that it already has been clicked because the arrow now is pointing down, and you see everything in there, and you see the rating is there. So anyway, again, I will go ahead and post another demo. I had talked about the demo called Zillow demo, where I'm going to show you how I found that data inside that HTML that we needed. And I'll post another one called IMDb demo showing you how I was able to find this, just so that you can kind of just see how it works. I mean, you might be able to find it okay, but there's kind of a trick to being able to narrow this down. So that's why I need to actually show you in the demo. Okay, so that's what we have done for this particular first movie, The Shawshank Redemption. We have found that the title, we found where the title is located, what type of tag it is in, and then we've also found where that rating and rating is in. Now, if we expand a few more of the elements, we'll notice, and then actually sometimes it helps to not only expand but then contract a lot of them, so that if you make a lot of the arrows side arrows right pointing right, then you kind of can see the overall pattern. So you know, when we had that one, the first one expanded, you just saw a bunch of stuff here. But if we kind of look further down and don't expand some of these, you see that each row seems to have those same TD tags. So it starts with poster column, then title column, and so on. So you can see that you could guess, and it would be true, that each line then is representing a different movie. And it's within those tags, those TD tags, is where we're trying to find that information for those movies. Here's the strategy that we'll use. We're going to use the requests library to make a request for the web page, and then HTML will be returned. Then we're going to use the Beautifulsoup library to go through the HTML code, pull out the names and years of the movies from the TD tags with the class of title column, and then pull out the ratings from the TD tags with the class of rating column IMDb rating. Then we're going to store that data that we find in Python lists, and then we will create a pandas data frame from the data in those lists. Okay, so let's go, and I'm going to talk through these commands. You might want to just work along with me, so you might want to open Spyder right now and then just type in these individual commands as I'm explaining them, or if you want to just listen to me and then you can go and type those in later. How we would do it is we would open Spyder and then we want to import the requests library. Now we could have just said import requests and that would get us the entire library, but sometimes you think you know that you don't need the entire library, you just need one little function out of that library. So this is another way then you could do that. It's just say from requests import get, and then we're just importing the get function from the requests library. Okay, now here is this URL that we had noticed that would be used in order to find these top-rated movies. And then we use that get function from the requests library. So on the right hand side of the equal sign, we say get and then pass in that URL that we just the actual string that we just set as the value for this URL. Okay, so that passes in that long URL, and so it goes ahead and gets that, and then any HTML that is associated with that URL then is going to be put, and then look on the left hand side of the equal sign, it's going to be put into the object that's called response, because we've called it response. So you can call that anything you want. We'll just say we want to call it response, so we want to say response equals and then get that URL. So that's going to pass that URL into the get function, and then whatever HTML is there at that URL gets saved into an object called response. Now, if we just want to see what's there, this isn't going to get us anywhere other than just give us some peace of mind that it actually got something. We could type response.text, and that would then print out the text so that we could see what's there and make sure there really is some HTML in there. And this is what we would get. It would look something like this. A lot of stuff, all of the HTML is kind of smashed together and a little bit hard to read. So right here, it doesn't really matter because we already know where to look to find the data. So we're going to have Python look through and find those tags that we know the data is in, and we don't actually have to look through and find it ourselves. So it's not a problem that it looks like that. Now that we have all the HTML from that web page, we need to import Beautifulsoup that's going to help us pick out the parts of the text that we need. So first of all, we're actually importing the library called BS4, but there is a function in there called Beautifulsoup that we're going to use. So the command we would use is from BS4 import Beautifulsoup. Then the next line is we have an assignment operator, equal sign here. So on the right side, what we're doing is we are calling that function, the function called Beautifulsoup, and inside the parentheses we have some things that we're sending in to that function. So we're sending in that response.text. So that's that all of that HTML that we just got from our code. So we've got that response.txt. We're passing that into Beautifulsoup, and also we just have this other parameter called html.parser that we send into. So there's some kind of setting or something where we have to say what we're using. So anyway, don't worry about that. You wouldn't have to memorize that or anything, but that's just something else that we have to send in. Okay, so that's on the right side of the equal sign. What we get from that after we send that information into the function Beautifulsoup, what comes out of that function is we want to save into something. So we're going to call that, we can call it anything we want. We're going to call it soup object. So that's just our soup object that we get after we send in that HTML into our Beautifulsoup function. Okay, so all of that HTML is within this thing called soup object. Now, remember that we saw that each TR tag contains information about a different movie. So our script is going to be looking for all of these TR tags and then pulling all of the information within each TR tag in for each movie. Now there is a problem because there might be more tables other than this one table that we are looking at. You know, I don't know, I hadn't looked, but we never want to just assume that there's only one table within that HTML. So we wouldn't just want to say, hey, find the table and get all the TR tags, because there might be other tables. So what we want to do is see if we can make sure that we specifically target this one table that we are interested in. So if we take a look up at right above here, it says tbody class equals lister list. So that will help us then narrow down which TRs we're really going to be pulling out. We want those TRs that happen to be a part of this table body with the class of lister list. So that's just an observation we want to make, and now we're going to use that observation, and within our code we're going to say, let's just first of all get everything that's in this T body with this certain class of lister list, and then let's get all the TRs inside there. And that way we'll make sure that we have the correct TRs that have the actual information that we want. Okay, so this first one is what we're going to do to limit and only look at what's in that T-body tag with that particular class of lister list. On the right side of the equal sign, we're starting with what we've already got was that soup object that we already assigned, and we say soup object dot find, and that's a function within Beautifulsoup that we can use, so we say find, and then we say what we want to find. We want to find this T body, and we want to find the one that has this particular list of lister list. Notice we just have to put class with an underscore after it when we pass it in. So anyway, we're telling it there on the right hand side what to find, and then on the left hand side we're naming what comes out of it. We want to say what we want to call it. So we want to call this movie table. So we're just saying, okay, this is the table that we have all our information in, so I'm going to call it movie table. And so now I will have just that T-body information with all of the TRs that I really want. Now I need to take all of those TRs and compile them into a list, because I just, I don't want just this big long HTML code. I want to organize and take each TR and look at it as a separate entity, as a separate movie. So we can use this function called find all. On the right hand side of the equal sign, we're going to start with movie table. That's just what we just created in the line right above it. We're going to take what we just created called movie table and then call the find all function. And then we have to say what we want to find, and we want to find all the TR tags. So we pass in TR, and then on the left-hand side, we're going to decide what we want to call it. And when we find all of these TRs, it's going to then create a list because there's more than one TR. So we'll call it movie list because we know there is going to be more than one of these. Okay, so we call it movie list. So movie list equals movie table dot find all TR. And again, that's going to take the HTML from within each of those TR tags, and then all of those will together be compiled into a list called movie list. Okay, so far we just have this one big list. Every element in the list represents a movie, but each element in this list has just a bunch of HTML in there. And we need to pull out what exactly, just those little bits of data that we want. So we're going to create some lists, and then anytime we find something of value, we'll put it into that list. So since we want the names, the years, and the ratings of these movies, we'll create a list called names, one called years, and one called IMDb ratings. The way you create a list here in Python is just to have the name, whatever the name of your list you want, and then equals, and then these two brackets, a left square bracket and a right square bracket. And that's, so names equals, and then right square bracket, left square bracket is creating a list called names. The next line creates a list called years, and then we create one for the ratings too. Now we create these lists using these statements, but those lists will be empty until we put things in them. Okay, so at this point we will have those lists, but they will be empty. Okay, now we need to go through all of that HTML in each of those elements for the movies and pull out the name, the year, and rating, and then put that information in these lists. Okay, so now we're going to use a loop, and I think I've said in the past that we don't do a lot of programming when it comes to Python in this class. It's more just calling, calling functions and running commands. But this is actually this is going to be a loop, which we would definitely consider that we are programming. So anyway, this first line says for movie in movie list. So remember, movie list is that list of all of the HTML for each movie. And so we're going to say, in this, using this line, we're going to say we want to look in that list called movie list, and we're going to call each, we're going to go individually one by one and take a look at each element. And we're saying here, since we say for movie in, that means, okay, one by one I'm going to look at these, and each time, whichever element I'm looking at, I'm going to call it movie, because I said for movie. Okay, so I'm saying I'm going to call each element as I'm walking through one at a time. I'm going to call it movie. And then what follows is then what we're going to do with that particular element in the movie list. Okay, so here's the first thing we're going to do. We want to pull out the name of the movie in that, for that element. And so we had noticed in the past that the movie names are inside the TD tags with class of title column. And we noticed that's where we found the names. But now let's look at the HTML here, and here's where we see TD class title column. And we see that the name is definitely in there. The Shawshank Redemption is in there. But there's a lot of other stuff besides just the name. And we don't want to pull out any of that other stuff. We just want the name. So we wouldn't just say find movie.find TD class title column and get that, because that would get all this other stuff. So we actually narrow it down further. We notice there is a tag, an A tag inside this TD tag. And that A tag, that's a link tag, and it says A, href, blah, blah, blah. That's going to be the when if the user would click on that name, then that's another page that it would go to. So anyway, that's an A tag, and notice inside the A tag, besides all of that, you know, the href and everything like that, but inside that you see just the name, The Shawshank Redemption, and that's what we want to pull out. So then back to our code, we say movie.find td class equals title column, and we're finding that first, and then we're going to say no, but now let's go inside that. So we say dot A, meaning go inside that and find the A tag, and then we say dot text, saying go inside the A tag and get the text, which would be The Shawshank Redemption. Okay, so that the right side of that equal sign is narrowing down and getting the text that we need. And then on the left-hand side of the equal sign, we're going to put what we want to call this. And since it's the name of the movie, we'll just call it name. Now, that's one little name, but we want to put that one little name in the list of names that we've created up above. We created a list called names. So we'll put our new name into the list called names. So we say names, which is our list, dot append name. So we're passing in our new found name into our list. So the first time it goes through this, it will put the very first name into this list. But then, and we're going to do some other things here before it would move on to the next element, but after it would do everything that we're going to be telling it to do here in a second, then it would go to the, here it would start with the first movie and find The Shawshank Redemption and put that name into this, the list called names. Then it would go to the next movie and find its the name of the next movie and put it in also. So it's going to be doing this for every movie in our list that we already have called movie list. Okay, now we'll do the same thing for year. How will we identify the year? Looking at the year, we see that the 1994 is inside a tag called span with the class of secondary info. So we'll say year equals movie.find span class secondary info, and we want just the text inside there, which would be the 1994. There are parentheses around there, and we'll learn how to deal with that here in a little bit. But for now, let's just pick up all of that, the parentheses, and then the actual year. And then, now we've found that year, we want to put that into our years list. So we will say the list called years, we want to append our new year to it. So years.append, and then pass in our new year. Now we'll do the same thing for the rating. You don't see the HTML for that, but the rating would be found inside the TD with the class of rating column, IMDb rating, but it's also, there's a strong tag inside the TD tag. So you need to go inside that extra tag of strong and get the text. Now there's one other little extra part to this statement here, and you see that all of that movie.find stuff is in parentheses, and then in front of it it says float. So what that's doing is it's going to take whatever rating is found, so it'd be like a 9.2 or something like that, and it's going to turn it into what we call a floating point decimal. That's just a number. It's going to turn it into a number, and it's going to be might have decimal points in it, is all. That's what it means if we call it float. It might have some decimal points in it. So we're getting all of that and then changing it into a decimal number and then calling that rating. And then whatever we got for that, we're going to again go back to our main list. In this case, it's called IMDb ratings, and we want to put our new rating into that rating, that list. So we'll say IMDb ratings.append rating. Okay, so now we have our new rating in the in our list. Now, and then we're done with that loop. And so then what would happen if that's in our code, it's going to then go and do that for every movie in our list. So it would do that. I think there's going to be like 250 movies on, I think, on that page. And so it's going to go and do this 250 times. And so by the time we're done with this code, we're going to have 250 names, 250 years, and 250 ratings. And they'll all be in the same order, so we'll know that the first year goes with that first name, and the first rating also goes with that first name. So anyway, we have these three separate lists, but we're eventually going to put those lists together in a data frame so that then we can look at it as, you know, records and columns with records in them. With records too. Now it's important when we put this code in that you indent the lines, because that's how Python knows that these lines are meant to be part of that loop. So if you don't indent the lines and just that second line, name equals movie.find, and you just have that over to the left, as far left as you can, it's going to think there's nothing inside that loop. So it's going to look for indented lines coming after the line for movie equals movie list. It's going to look for the indented lines, and those that are indented then it knows is part of that loop. Okay, so be sure and do that. Okay, so now we have those three separate lists, and now we need to put them together in a data frame. We have used pandas for that in the past, so we're going to use that again. So we would import pandas as PD, and then df equals, and this is something we haven't seen before, but what this line is doing is taking our individual lists. We had a list called names, one called IMDb ratings, and one called years. And it takes those lists and puts them into a data frame. And it also says, allows us to say what we want the columns to be called. So we're passing in, first of all, movie. We want our list that is called names. Those are really our movies, right? So we might want to call that column movie. So we're going to have one column in our data frame with all of the names, and we're going to call that column movie. Then we're going to have another column in our data frame called IMDb ratings, and we're going to call that column rating. And then years, we're going to put that list in our data frame and have that column called year. Okay, so we would have that, and now after doing this, then we would have a new data frame that has all of our movies, and it will have, for all of those movies that we found on that page, it will have a column called movie, one called rating, and one called year. And if we typed df at this point in while we're in Python, it would show us what we have in our data frame, and this is what it would look like. It's a little weird, you see that the headings of the column there on the top line don't really match up with the actual data. The movie and rating and year, those need to be moved over. But anyway, it's all correct. It's just that Spyder doesn't really make this format look that great. So anyway, there is one problem though. We see that those years are in parentheses, and that's because they were in parentheses in the HTML. And we might not want that. We probably don't want that, because we'd like those years to be looked at as numbers. And if there's parentheses in there, we can't look at them as numbers. And the reason we might want them to be numbers is maybe we'd want to sort them by order of year. We might want to get an average of year or something like that, and we can't get an average if we just have some character strings. So we need to get rid of those parentheses. So that's what we'll do next. Okay, so looking at all those years, if you want to actually do this, you don't really have to, but if you look at the years represented, you could do that by typing in df year and then .unique, and that would just show all of the unique years. So that means if there's a bunch of them from 1994, it's not going to list 1994 a whole bunch of times. It's just going to list which years show up at all. And so here's what we get, and we see that everything looks good and like it should be, except we have those parentheses. So what do we do to get rid of those parentheses? Well, if we look at like just one, for example, 1942, we see that the first character is a parenthesis and the last character is a parenthesis. We want to get rid of those and only pick up those characters that we really want. Now, what ends up happening usually when we're working with computers is when things are numbered, usually we start with 0 for the first one. So if I'm talking about the first character of this character string, I'm not going to call it, it doesn't have the index of 1, it has an index of 0. We start with 0 and go on up from there. So we would say we want to get rid of the character in the 0 position and the character in the 5th position, and we want to keep the characters in the 1 through 4 position. So also though, as I said before, we probably while we're doing this, while we're stripping out those parentheses, we'd also like to change those to numbers so that we could get an average at some point if we want to. So here's what we do to accomplish those two things. On the right side, well, first of all, let's look on the left side, df year. So what's happening is we're replacing, that just represents a column in our data frame, right? The column that's labeled year. We're going to be replacing that with whatever we have on the right-hand side. Okay, so on the right-hand side, we're starting with what's there, df year, but then this .str is just finding the particular parts of that string. And if we say 1:5, that means we're going to start on at the character in the position 1, which is not the first character, right? Because the first character is in the position 0. So we're starting with position 1, which is the 1 in the 1942, and using this command here where we're pulling out values, after the colon, you'd think we'd put 1:4 because we want to go from 1 up to 4, but you need to put one more, make that second number 1 higher, because we're saying, what that's saying is start at 1 and go up to 5, but don't include the 5. So it's really weird. You'd think they would have set it so that you could have a 1 and a 4 there, and that would get from 1 up through 4. But no, you have to say 1 up through 5 because it's assuming that it's not going to, it's going to go all the way up to, but not including whatever that last number is. So if we have 1:5, it's going to go from 1 up to 4. And then if we tack on to that .as type int, it's going to turn that character string into an integer. So that's what we want, because we want it to be looked at as a number. And an integer is just a number. It's a whole number that's not going to have any decimal points, and we won't have any decimal points with these years anyway. Okay, so that's what we will do to fix our years. So now, after we do that, here's what we have. If we were to look into our data frame, this is what we'd have. It looks good. We've got the titles, and we've got the ratings, and we've got the years. And those years don't include parentheses, and it would be looked at as, those years would be looked at as numbers, so we could find an average or something like that if we wanted to. Now that our data frame holds the information that we want, we can save that to a new CSV file. So we'll type df2 CSV and then decide what we want to call our new CSV file. And I'll call it topmovies.csv. Remember, if you use a command like this, it's going to be saving that CSV file to where your working directory is set. So up at the top right of Spyder, that's you've set where what your working directory is. So if you're running this and not finding the file, then you just know that, well, maybe I don't have the working directory set, or I'm not looking in the right working directory. So anyway, just set that where you want it to be. So if you want to save this on your desktop, then you would set that working directory to the desktop, and then you could find that. You probably don't want to put it on your desktop. You probably have a special folder that you use for this class. So that's where I would put it if I were you. So then we would have a new CSV file and could use it then later on to create a model, or I don't know, do any kind of data analysis that we would want to. Now, I'm going to give you a lab to do, and you'll be doing something similar to what we've been doing in this demo. Something that you'll need for the lab. Sometimes we might have some data in our web pages that we're trying to pull out that have some spaces, either in front of the data or after the data, just empty spaces that's basically invisible. But when you would pull it in, these empty spaces would be there, and that might not be what you want. So there is a function called getText, and then you can put inside that function strip equals true, and then when it pulls in some text inside, if you're looking inside a certain tag and you're wanting to get the text, if you say getText strip equals true, then it's going to strip the white space out, any white space in front or at the end of these characters. So and also when you look at that HTML, you'll see a lot of /ns, and that's where saying go to the next line. So the strip, that same command will also get rid of those /ns. Okay, so looking down here, title, you're going to be if you had something like this, title equals car.find, you're looking in the H2 tag with a certain class, and you're looking in an A tag, and you're finding the text. Instead of that, if you want to strip the white space in front and the end, you would just, instead of text at the very end, you would say dot get text strip equals true, and it pulls in the text, but will strip it at the same time. Okay, so keep that in mind. You'll probably need to use that in your lab. Okay, so here's what you're going to do for your lab for this lesson. You're going to go to www.cars.com and perform some kind of a search. You can do any kind of search you want. Choose a city, maybe an upper limit or a lower limit, any kind of, whether you want to look for new cars or used cars, just any kind of search you want to do on www.cars.com. Scroll down to the bottom of the list, and because on that website, you can choose how many you want per page to show up. So scroll down and choose 100 per page so that you'll get a lot of different cars. So do that. And then once you're happy with the search and you see a lot of cars on your page, then copy that URL, because that's what you're going to need to pass into Python, and then write a Python script to scrape the data and put it into a pandas data frame. And then you can choose whatever information you want to scrape, but at least get the type of car it is, like make and model, the price, and the mileage. So definitely get that. Once you get all of that into a data frame, Then use the describe method to get some information about the data. So that describe method is something we've used in the past, so that you could say, what's of those cars that you found, what's the, what's the average price, or what's the maximum mileage, that kind of thing. That's the kind of stuff that you would get from the describe method. Okay, and so anyway, you can look at the actual lab itself to get more details on that, but that's kind of an overview of what you're going to be doing. Just in case you get stuck, I am going to post a document called Help with Web Scraping Lab that you can look at if you get stuck. Now, try to do it without looking at it. It's just that some people are maybe a little bit, confused and don't know where to go. And so if you are confused, definitely take a look at that, and that might help. Also, feel free to contact me and I'll help you too.